I'd like to use the awesome free website desmos.com to take a look at exponential transforms and understand how the transform equation shows us what should be going on in the graph. So the first thing for us to notice here is this is the actual transform equation. Y is equal to a, that dot means times a times b to the power of x plus c. So you'll notice for exponents we have the x, the power is, the x is the power, it is an exponent there. Now, these are what we call sliders, where I can change the value of c in the equation, and I can change the value of b, and I can change the value of a, so that we can see what these changes look like. But as a reference, right now I've got c set to 0, so that means plus 0, b is set to 2, so 2 to the x, and a is set to 1, so I don't have to write that, it's just 2 to the power of x. So this dashed equation is our reference, that's what we're comparing against if you want. So that's where we're starting. And let's look at each of these in turn and see how they affect the graph, what happens to it. So if I start moving c, what do we notice is happening here? As c is increasing, here c is now equal to 3, what's happened compared to where it was? We can see here it's actually shifted 3 above, so it's gone up by 3. And as we watch that cycle through, you can see it also going down, so when c is negative it's going down. So what we can do here is add in a little hint for ourselves while we watch that. Oops. C tells us the up / down shift of the graph. And here we have positive for up and negative for negative down. So if you see a C, something added or subtracted out the back, if it's positive, you know the graph's been shifted up, and if it's negative, you know the graph has been shifted down. Okay, so we'll go back to 0 with no shift. Back to our original equation here, c is equal to 2 to the power of x. And let's take a look at b. What happens if I change b? So b is that actual, what we call the base, that's why we're calling it b. It's the base of the equation. And if I change it, let's try to make it bigger. What do we see happens? The graph's actually getting steeper. It's increasing faster and faster. And if I make that really steep, so we can see that when b is a bigger number, it's starting to make it steeper, and as it gets lower, it's less and less steep. And something interesting will happen here as we keep going down. When b is equal to 1, nothing's happening. Mathematically, what's happening there is that saying 1 to the power of something. Well, 1 to the power of anything is always going to be 1. It doesn't change, and that's why we get that equation there. But aside from the special case of 1, here we have something bigger than 1, it's increasing. And here if we go less than 1, swaps to the other side of the graph. It's like it's flipped around on the y-axis. And here we see it is decreasing. And if I have a really, really small value of b, you can see it decreases really rapidly. A slightly bigger value of b decreases less rapidly. So let's take a look at b and look to think about what the hints are here. So b tells us the rate of increase or decrease. And let's look just a little bit further at it and make sure we understand what's going on here. So when b is equal to 2, this basic equation that we've got here, 2 to the power of x, that means that it's doubling every single time. So if you look here, starting at 0 and 1, so x is equal to 0, we've got a start value here of 1, an initial value of 1. In the next sequence of time, so going over 1 on the x-axis, it's now equal to 2. Well, 1 times 2 is 2. And if we continue that trend of doubling, that's what exponential will be, timesing by the same amount every time. 2 doubled is going to be 4. And 4 doubled will be 8. So we can see it's equal to 8 there. And 8 doubled will be 16. You can see it's equal to 16 there. So what happens here is this graph is doubling every single time. If we look at it from the other way, the value is smaller. Half is an easy thing to deal with. Let's look at these numbers here. Starting over here, when x is equal to 4, I have a value of 16. And in the next time frame, as I go over, I'm down to 8. So 16 times a half, or basically dividing it by 2, 16 times a half is going to be 8. Times by half again will get us to 4. Times by half again will get us to 2. Times by half again will get us down to 1. And you can keep going. Times by half again will get it to 1/2, 1/4, and so on. And something interesting about the exponential graphs is that they'll never actually reach 0 when this particular transform. They kind of level off with what we call an asymptote. So it'll keep getting just smaller and smaller and smaller and smaller and smaller, but not actually going past the 0 here. So b tells us the rate of increase or decrease, and in a sense this is the, as an example, doubling or halving. It can also be used in terms of finance to tell you percentages, such as something like, decreasing by 20%, or maybe increasing by 15%. So that would be something like a loan, or the value of a car that decreases over time, the interest rate at a bank if you're saving things. That's where the exponentials can come in as well. So again, C gives us the up-down, B tells us the rate of change, whether we're doubling or tripling, or halving, or maybe even down to 1%. So again, watching that go through. An important thing here as well to notice is that when B is greater than 1, it's increasing. When B is less than 1, it's decreasing. So we'll add that in here as well. B greater than 1, increasing, and B less than 1, decreasing graph. Okay. So let's take B back to 2, just as our basic, what we've had. And let's look at A. So A is that value in front, and this is sometimes called the initial amount. But let's look and see what's going on with that when we change it. We can get it all in here. So A is equal to 1. Let's start playing with this. As A decreases, it's a bit hard to read. I'll go by hand here. Okay, so as A is getting bigger, we notice that it's actually shifting up the scale. And when A is equal to 10, you'll notice here on the graph it's actually starting at 10. If we go back down to 5, it's starting at 5. And as we get smaller again, down to 1, it's starting at 2. Sorry, it's starting at 1. And if we get even smaller, it'll start at a lower value as we go along. So A is basically giving us an interpretation of what we're starting with. And if you start with a value of 1, well again, and you're doubling it because your B is equal to 2, 1 times 2 gets you to 2, times 2 gets you to 4, times 2 gets you to 8. But if we start with more, if we start with, say, 3, at the start I'm at 3, so I've already got 2 more than before, so at the start I'm at 3, and if I double that, I get to 6, and if I double that, I get to 12, and if I double that, I get to 24. So this kind of goes with that idea, if you put more money into the bank at the start, you get better returns on it because you're doubling more and more money each time. So you can see that graph actually increases a bit faster and will pay off for you better in the end. So let's watch A and write ourselves a little note for it. Yep. Here we go. So A tells us the initial amount, what we have started with. Also shows us the y-intercept. This is, for instance, the initial deposit into a savings account. If I start with $100 and I put it into my account and it increases by 5% every year, the next year I'll have 105. And away you go with it. So the bigger the value of A, the more money you're starting with, but your rate is still the same. In this case, if I start with an A of 5, this is a good example again. So remember, the dotted line is an A equal to 1, that's just 2 to the power of x. The solid line here is 5 times 2 to the power of x, so 5 times as much. So here I'm increasing, going up from 1 to 2, from 2 to 4, I'm doubling. Here I'm also going to double, but it starts and takes bigger steps, but each time it's still a double. From 5 to 10, from 10 to 20, from 20 to 40. So here I'm still doubling, the rate's still the same, I'm just starting off at a different point. So, kind of to recap for us, in the general form, A is equal to B to the power of x plus c. C gives us the up and down, where our graph is actually going to be. B gives you the rate that it increases by, whether it's doubling or halving or decreasing. Again, B bigger than 1, it's steep. B less than 1, it is decreasing. And A gives us the initial amount, what's actually changing here. So if A is a really small number, like 1, you're just starting off with the very basics. But if A is a bigger number, you're starting off with more and decreasing more and more off of that. And it gives us the y-intercept, but I should say in here, A plus C will give y-intercept. Just because when it's transformed, if you've shifted it up or down, that will change where you go through the y-axis. Okay, so that's the breakdown for you about the transforms for the exponentials, and we'll take a look at how to actually use these to write the equations now. In the next video, that is.